Yes, my name's Philip Cooper, and with Sylvie and little Amelia here, we have an air chalet and hangar on the airfield. We own an L200, a LET 200D, and an air tour over there. And thanks to Bruce and the other guys on the field, I have an interest in early aviation, which has led to the manufacture of a new Bristol fighter. The format of the next half hour, what I thought I'd do is give you a little bit of an overview of the aircraft, give you a little bit of history about how it came into being. I'll talk a bit about Bristol, the early days of Bristol, and how we ended up with probably the best two-seat fighter in the First World War. So we'll just run through that, then we'll get on to the manufacturing. We'll talk about what stage I'm up to in the build. I'll talk about some of the processes. I have a couple of bits and pieces here to show you as well, and I'll give you an idea of where we're going with it and what sort of time frame for the build. And we'll finish off. I've just got a 6-minute little video of 3 Bristol fighters flying in formation in the UK, which is quite a good little video to finish off with. So the Bristol fighter comes in two versions, basically, the F2A and the F2B. There weren't many F2As built. They very quickly moved on to the F2B. So we're talking about here an era of 1916. And the aircraft itself, as an overview, is obviously a biplane. It has a Rolls-Royce Falcon 3 engine. That was the most dominant engine at the time. They started off with various types of engines, including Hispanos, Beardmore engines. They were basically unsuccessful, but they moved on to this higher horsepower engine, and that really was the beginning of the Rolls-Royce V12 series of engines. So it was the very first. It was a very good engine. It's got a very large propeller. It's a 3-metre propeller made out of Honduras mahogany. It has the pilot sitting just behind a fuel tank, an instrument panel, the pilot in here, and then we have the gunner's position. And the aircraft was designed specifically to give the pilot better view, and hence how it's sitting above the bottom wing, so the pilot could see over the top wing, and also the way the fuselage slopes at the back is very deliberate. It gives the rear gunner a better field of fire. So the single or twin Lewis machine guns are on a scarf ring, which means that the operator can grab hold of a handle, swing the gun down, let it go, lock it, and then fire. So a very good field of view. I'll talk a little bit more about the development of the aeroplane in a minute. This little pump here, see the little propeller? That's to pressurise the fuel system, so the tanks were pressurised. And a lot of the technology in this aircraft we see in aircraft today, in modern aircraft, and I'll touch on that as we go. So, why build a Bristol? Well, it's very, very rare. There are only 2 Bristols flying in the world at the moment, one in the UK, one in New Zealand. The aircraft has a very strong connection with Australia. We had 3 squadrons that operated Bristol fighters, predominantly the F2.b, this one. It was most successful in Palestine, #1 AFC. The Australians virtually cleared the skies. There's some very famous statements made about how well the Australians performed in this aeroplane. They cleared the skies of the Turks and the Germans, and they were very aggressive pilots. Interestingly, this aircraft typically has a max cruise speed of 123, 125 mile an hour. The Australian pilots used to dive them up to 245 mile an hour. So it was virtually, they would push the nose down and full power, straight for the earth. And no other aircraft could match that. And because it's a draggy aeroplane as well, they could pull the power off with someone behind them, and then they would go shooting past, and then they would just shoot them down. After the First World War, airlines such as Qantas in the early days, Western Australian Airlines, they bought the civilian version of the Bristol fighter. It was called the Bristol Tourer, And the very first air service in Australia was in Western Australia with Norman Brearley in a Bristol Tourer. So the very first trans-Australian flight was in a Bristol Tourer. So the aeroplane has quite a lot of history in terms of Australia. So I thought, well, the story needs to be told. It's a rare aircraft, so let's have a go at building one. Now, this man here, his name is Sir George White. He's a very significant figure in the development at Bristol. He was born in 1854. He had an untimely death, a heart attack, in 1916. But basically, he became, in 1887, he became the managing director of the Bristol Tram Company. Now that's interesting in that Bristol, in the town of Bristol, at Filton, they actually built the very first electric trams in England. So that's where it all came from, and he was in charge of that. Being the first baronet, he was an English gentleman, and he stood very high in English society as well, so he's very influential. In fact, as a baronet, you stand higher up than anyone that's got a knighthood or such. So he became interested in aeroplanes. He went over to France in 1909, and Wilbur Wright was flying in France, and he saw Wilbur, he spoke to him, and he said, that's what I want to do, I want to build aeroplanes. So he came back to England, and then he formed the new company called the Bristol and Colonial Aeroplane Company. He actually registered 4 names, and those names stood the test of time, the Bristol Aeroplane Company, etc. Okay? But in that period it was called the Bristol and Colonial Aeroplane Company. Now I've got a picture here just out of interest of, that's Bristol. So are they electric or are they horse-drawn trams? Amelia. Can you see any horses pulling the trams? Yeah, we've got the carriages, but not the trams. In fact, if you look there, there's a boom, isn't there? So they're electric trams, and they were the first ones that were ever built. So they had a very highly skilled workforce to draw on when they were building aeroplanes. So what he did, to kick it off, he went back over to France and he bought 6 Zodiac aircraft off the French. And he brought them back in pieces, back to Filton in Bristol, and he assembled them. And just before they were test flown, he took them to the Olympia Air and Motor Boat Show. That's in London in 1910. So here they are, Bristol's first assembled aeroplanes. So after this show, they were then taken away for test flying. Now they had a Dirac engine in them, only 50 horsepower. Guess what? Didn't fly. Okay, and yet the French, when they sold them, gave them a guarantee in French that these things will fly. And the best they got out of them was just a short hop. So as you can imagine, George White was pretty upset with the French, and so he wanted to sue them for 15,000 francs to ensure that he got his money back. But being Napoleonic law and being French, there was no way he was going to get his money back, so he dropped the case. Now, from this, he then moved on and decided to buy Farman biplanes. So he bought some Farman biplanes. They looked at the aircraft and they thought, this is a bit rudimentary, so they decided that they would redevelop the aircraft, and they put the new 50 horsepower Gnome rotary engine in it, and they then went out to test fly the aeroplanes. The trouble was that the workers at Bristol were really nervous about the test flight. They thought, well, we've had that experience with the Zodiac, so apparently all the workers, when the test flight occurred, were down on the ground to see how high the wheels would get off the ground, and thinking that the aeroplane would just do a little hop. But guess what? Away she went. And that aeroplane became known as the Bristol box kite. Okay? It was very, very successful, and it had a first. Not only was it a good flying aeroplane, but it was the first aeroplane in England that they actually made a transmission, a radio transmission from. So it was the very first time. Now, the military became interested in this aircraft, and all flights were conducted in front of the military only. There was no, at the early development stage, they didn't put it out for public display. So, eventually, George White, being a businessman, thought it would be a good idea to put it out for public display. So, at Bristol Downs on November the 10th, they had a flying display. And ladies at Watts Bridge, note the fashion. As we get more World War I aircraft, that'll be the dress code. Anyway, that's a very, very famous photograph taken at Bristol Downs in November 1910. Now, one of the ladies was actually taken for a flight. And trust me, it's a really scary experience sitting on top of a Bristol box kite wing with the noise and the wind and the whole lot, being dressed especially like this. It was a little bit of a disaster because the lady lost a hat during the flight. So things didn't go all that well. Anyway, as far as the aeroplane was concerned, it was good. They went on to make 78 box kites because the military started ordering these aeroplanes. Australia had 2 of them. In 1911, Australia purchased a box kite. It was in storage up until 1914. And then Australia actually built one from scratch. And it was the first ever military aircraft that Australia built. So, and it operated down at Point Cook as well. Now this, as we're leading now up to the First World War, this is about 1910, Bristol had a lot of, George White employed a lot of good aeronautical engineers, and they started developing monoplaned aeroplanes, biplaned aeroplanes. They experimented a lot. Pierre Pryor was a Frenchman he employed, and he actually designed this monoplane here. This is the factory. Notice the workers. This is at Filton in Bristol. Notice the workers are all dressed up nicely. I want you to pick the foreman in that picture. It might be a little bit...
He'd have a white coat, wouldn't he?
Well...
Bowler hat.
Yeah, very good. Yeah, trust Bruce to know. Yep, there he is. See? In fact, what I've done, I put a little ring there and you can see the bowler hat. Okay, so here's the foreman of the factory. But as you can see, it's nice and clean, and Bristol were known as this. In the old days of shipping, you've heard of the term ship shape. Well, after the manufacturing at Bristol, the term was ship shape and Bristol fashion. And that's how that term came into being. So, anyway, as we move on, closer now towards, there's the Pryor monoplane. So we'll talk, before we go on and talk about the designer and the Bristol itself, let's just have a think about the aeroplane. It was initially built as a reconnaissance aircraft, okay, to replace BE-2s, FE-2s, those type of aeroplanes. But the designer, Frank Barnwell, very quickly recognised it as a fighter. Now that doesn't mean a fighter in the air, it means a bomber in those days, because they used the term scout for fighters as we know it, okay? So it became a fighter, that's why it's changed to F2.b. Max speed, it's actually 123 mile an hour, I forgot to change that, but yeah, maybe ours will go at 125, we'll see how we go. Dive speed up to 245, and as I said, the Australians were very, very good at this. The weight of the aeroplane, the combat weight is 3,243 pounds and the empty weight's 2145. I think we're going to be under that, our operating weight, for different reasons. I'm targeting about 2,900 pounds and it'll have the same horsepower, so ours should perform a lot better, and we're fitting a supercharged engine as well, so we can go high altitude. It was armed over the V12 engine at the front, had a Vickers machine gun which fired out through the radiator, out through the propeller. Forward firing Vickers, and in the back it had 1 or 2 Lewis machine guns, and it also had bomb racks. Now we're going to actually build the ribs to take bomb racks in this aeroplane, so it will be fitted with the racks. Why? Because we might as well. That's right. So if I get upset with anybody, we've got 240 pounds worth of bombs there. Service ceiling, you'll see different figures, typically 18,000. However, Bristol's were observed at flying well over 20,000 feet. But the pilots were suffering from hypoxia, and it was very cold, obviously over in Europe as well. So they tended not to, this was about their service ceiling. The engine was the, as I said, various types initially. The Rolls-Royce engine started as a Falcon 1, it went to 2, 190 horsepower, 2 was 200 and something horsepower, then it went up to the Falcon 3, 275 horsepower.
That direct drive, was it?
No, it was a geared engine. I'll show you a picture of the engine in a minute so you get an idea. Sea level rate of climb was about 900 feet a minute, so about 15 minutes to 10,000 feet, which was pretty good for its day. As I said, our Bristol, I'm anticipating a better climb performance than that. Endurance about 170 litres of fuel, which gives you about 3 hours. It's in 2 fuel tanks, one's behind the engine and one's under the pilot's seat. For safety reasons, we're actually going to incorporate a modern bladder tanks inside a container. We're not going to have the steel original tanks there. So, and the forward tank actually had a hole in the middle of it that the Vickers gun sat through. So it was quite a unique design. Actually, at the end of this, I've got a picture to show you that. So the aeroplane itself was designed. The initial design, the type RA and type F2.b were reconnaissance Bristols. They were designed to replace the Armstrong Whitworth FK8, the Royal Aircraft Factory RE8 and the Royal Aircraft BE2. And of course the BE2 is famous because Geoffrey de Havilland designed that aeroplane. What do you think the R stands for? Anybody, Bruce? Reconnaissance, good. And the E is experimental, yeah. Experimental. Sometimes you get a B as well. That's Blériot experimental, for example. So they stand for different things. So the first 3 aircraft, the Bristol fighter didn't actually come into being, but then later on, the Bristol fighter as we know it replaced these 2 aircraft, the FE2B and the 1.5 strutter, the swap with aeroplane. And Bruce knows why it was called a 1.5 strutter? Yep. Do you know? Yeah, do you know? Yeah.
Yeah, because you had 1.5 struts, or the length thereof.
Yeah, it was actually, yeah, that's right. It was the strut over the fuselage. It had a sort of short strut, and it looked like a W, and that's why it was nicknamed the 1.5 strutter. So these were the aeroplanes that the Bristol fighter was designed to replace. Now the man, a very famous man, a very famous designer, Frank Barnwell, he was probably one of the greatest design engineers during the First World War period, but he was one of the worst pilots. In fact, he died in an air accident, a self-induced air accident in 1938. But he was a master at designing aeroplanes. Between 1908 and 1910, he and his brother designed 3 aircraft, the third being very successful. In 1911, George White employed him. He knocked back a job with AV Rowe. So George White got him, set up a secret experimental design unit, and then eventually the Bristol fighter was born out of that. Right, there's the very first Bristol fighter, the F2, which became the F2A. It looks a little bit different. The early ones had a different type of engine in them. They had a an early Rolls-Royce engine in them, and it first flew, the F2A flew on the 9th of September 1916. There were only 52 aircraft built, so they very quickly moved on to the F2.b aeroplane. Now on its first outing, it was kept secret. The Germans didn't know about this aeroplane. It was kept top secret until it was It arrived on the Western Front with 48 Squadron, and they sent the first 6 aircraft out. Bad luck. Guess who they met on their way out? It was Rick, the Red Baron, true story, and he was in these Albatross aeroplanes, the D3s, and the Red Baron shot down 4 of the 6 Bristols. The reason for that was that they were still using the Bristol as a conventional reconnaissance aeroplane. So the idea was that they were flying in formation and they were flying lower down and they were relying on this rear gunner in the back to defend the Bristols. And they were just decimated. The Germans just dove through them and shot them to pieces. Not a good start. Not long after that, they sent out another batch of Bristols and they all ran out of fuel. And they all landed behind enemy lines, so they had to burn. The crew were instructed to burn the aircraft, which they did. However, very quickly, the pilots discovered that we shouldn't be using this aeroplane as a defensive aeroplane. We should be using it as a fighter or a scout aeroplane. In other words, it's highly manoeuvrable. It's got good speed range. It's got good handling for the time. And so we should be relying on the pilot himself to use the forward-firing Vickers machine gun to take out the enemy, and the bloke in the back would be there to just pick off anybody and to defend the aeroplane when required. Now, as soon as they developed those tactics, the aeroplane became very successful, so successful that the Germans, if they ever saw 2 Bristols together, they wouldn't go near them. They wouldn't touch them. They were very, very scared of the aeroplane. How many were built? By the end of 1918, 3,101 Bristol fighters were built, but they kept building them right up into the 20s, 1927, and they built 5,329 in total. So it was a very long-serving aeroplane. I think New Zealand had the last of the type in about 1932. New Zealand Air Force operated them. Okay, so not a brilliant photo, but it does show the Rolls-Royce V12 engine sitting in the Bristol itself. There's a firewall here. We're going to have a few problems with that because the Gypsy Queen engine that we're putting in the aeroplane is a bit longer, and it's got a supercharger on the back, so it's going to come into the fuselage a bit. We haven't quite finalised that, but the weight of the engine is just over 300 kilos, very similar to the Gypsy Queen engine we're putting in. This configuration here of the exhaust varies. The Aussie ones had a short exhaust stack, which is fine, except I've got to work out the proper rotation to make sure I'm not getting a mouthful of exhaust every time I go flying. But we're going to try and keep it true to an Australian aircraft when we build it. I'll just move on and show you the Rolls-Royce Falcon engine. Yes, it's a geared engine. Ratio at 2200 engine RPM at takeoff, so it's got a long stroke. It's geared down. The prop runs at about 1150 RPM. That's on takeoff. So it's like a big egg beater. Okay, a planetary gear reduction box. Now the Bristol, the Gypsy Queen that we're putting in has a reduction box as well, but it won't reduce the propeller RPM quite as much as what the Rolls-Royce did. Now there's the actual engine that's going into the Bristol. It's being done at a place called CFS, the Elvis Works in the UK. Now you probably heard of the Memorial flight in the UK with the Lancaster and Spitfire and Hurricane. Well, CFS do all their engines, and they've actually prepared a lot of these Gypsy Queen engines for racing aircraft, and that they know them well. So what we had to do, we had to actually, it normally runs inverted. It's fitted to Dove and Devon aircraft. We have a Devon come in at the fly-ins. So what we had to do, we had to redesign the engine, change all the internal oil system so it could run upright. Okay, and it's now being assembled in its upright position. Supercharger on the back, and this is where the propeller reduction box goes on the front here. So that's where it's at. When will it be running? Before Christmas. They're going to fit a test prop on it initially, and we're actually having the full-size prop made in the UK, and it will be running with that. So they're going to send over videos of all that happening. There's just another shot. See the supercharger, you've got induction coming through here, exhaust. Now the exhaust will clearly be only on one side of the engine, so we're going to have to dummy the exhaust on the other side, representing the V12. And not much space for our Vickers machine gun on top either. So. Now this is a Bristol Scout. It's actually a real Bristol Scout that's just been rebuilt. And this is a fairly recent photograph. Now the propeller is made of walnut, as it was in the First World War, and this same man that made the propeller has currently just started the Bristol propeller, which is made of, as I said earlier, Honduras mahogany. And where do you get Honduras mahogany from? You can't import it, you can't export it. It's extremely rare timber. Now, as you know, watching the shows on television, what they're doing these days in England, they're wrecking old churches to convert them into houses. Guess what? The pews are made of Honduras mahogany. So what the propeller guy does, he goes out and he buys this material. It has to be acclimatised even further. They have special rooms for that, which the timber's been set aside and been in rooms for some time now. And then, because the takeoff RPM on our aeroplane is going to be slightly higher, it's going to be about 1650 RPM, because we can't get the reduction down low enough. We're going to have to redesign the propeller from first principles. It will be almost full size, and it'll look just like a real one. Okay, but we've just had to tweak it slightly. So that's happening as we speak. The hub that we're getting designed to go on the Gypsy Queen spline is actually going to be a direct copy of the Rolls-Royce hub. So it's going to have the correct propeller hub. So that has to be machined in the UK and made from original drawings. There's an example of the propeller. As I said, it's a big one, and the reason that we chose the Gypsy Queen, it hasn't been done before in a Bristol fighter, is to try and get that prop RPM low enough to allow us to put a full-size prop on, because it just wouldn't look right if we didn't have the real thing.
What's that engine there?
In this one,
Yeah.
what's the reg? That's New Zealand 8096. Yeah, that's the UK. Yeah, because in New Zealand they put a 200 horsepower Ranger engine, which is a high revving, low horsepower engine, so they've got to run a small prop. I looked at the Ranger, but I discarded it for that reason. I couldn't get the original prop on it. So now the other thing too, for an extra 600 quid, I can have the leading edges done in metal. There's pros and cons for that. The Australian aircraft, sometimes they had them, sometimes not. No, I've got to really make a decision on that over the next few weeks. There's just another example showing the bomb racks. So these ribs in here are strengthened to take those racks. They had a few problems with compression ribs early in the war, failure of the ribs, but they were modified, and we'll be putting the modified ribs in it. Okay, I don't know how time's going. You're right, you've got enough time. Now, I've just put this here. This is actually a Boeing 737 component diagram, and I don't expect you to study this in any great detail. But what's interesting is in the 737, this is the mechanism that drives the tailplane. It's a movable tailplane trim for trimming. It uses an electric motor with a trim actuator that rotates a screw jack arrangement which moves the tailplane up and down. Being good old Boeing, not that other lot, it has a cable also attached to the drum. So when the electric systems fail, you can actually, on the trim handle, on the trim wheel, where is it there? There's a handle, you pop it out and you can wind it, and then it's got a cable down to that actuator, so your tailplane goes up and down. Yeah, fly-by-wire, that's it, yeah, I like that. Okay, let's wind ourselves back 98 years to the Bristol fighter, and we have a very similar system. So This is the rear of the aircraft. The leading edge of the tailplane goes in there, sits in there, and then through a series of cables and this mechanism and a trim lever, it moves the tailplane up and down so that we actually trim the tailplane. Just like the Boeing 737 and just like an Airbus, they do it a little differently. That's how it's happened. So these things, there were a lot of advancements. Even just after the First World War, they fitted a stick push system. So when the aircraft got near the stall, the stick would just go woof forward and stop the aircraft from stalling. And of course we've seen that in more modern airline aeroplanes. That's from a Bristol replica in the United States, just showing that mechanism. Now as you can see in this replica, I can look at that straight away and say none of this stuff's original because I'm so close to the project. I can pick up a piece of wood off of Bristol probably and tell you whether it's replicating the original or not. So this one's not, but it does show how the mechanism works. Also, this king post arrangement here, that goes up through the fin, it's connected to the top, then that's connected down to the leading edge of the tailplane, so the whole thing moves together. You know, even the bracing wires move as you're trimming the aeroplane. Now that's off the Bristol we're building, that's the tailplane. It's showing this superb welding here. He's not a bad bloke, the guy that does the welding. He gives me a bit of a hard time. He sometimes creates a bit of steam around the place, but yeah, so we've got this welded up now. The ribs are fitted in there and we're just getting the clips made. Now you've got to understand this is a scratch build aeroplane. It's made off original World War I plans. So I've got a limited number of drawings, but there's hundreds of drawings that we haven't got. And Shuttleworth won't release them. A lot of these places are not helpful. They won't release this information. So I've contracted an aeronautical engineering company and we've got to draw a lot of these components from scratch. And then they're put in DXF file, we take them to the CNC cutting machine and then we just cut them out and fabricate them from that. And that's a big process, it's costly, but it's the only way of getting this project done. So we're waiting, all these clips that attach the ribs, they should be delivered on Thursday. So we've got some more work for Vern to do. He says with a smile. Silver soldering, I believe. Yeah, now there's an example of a rib. I brought one along. Now I know that's a tailplane rib by its shape. So that's made out of Canadian spruce, aircraft grade ply, and we're using the Stewart system of covering, which is a non-toxic system, and Bill's fully au fait with that system. So that's actually treated with the Stewart system as we speak. So that's just an example of one of those. We'll move on in a minute to elevators. There's an elevator rib. Okay. Now, of course, it has a spar through it. Okay. So you can imagine that would be difficult to fit. So when you make it, the top is only tacked. That's not glued. That's not glued, and that's split. That comes apart. That's just tacked because each rib has to be fitted into the frame and assembled and glued, and then it can be clipped into the actual elevator. So in these things you've got to think ahead. Well, how is this going to happen? So that's how it's made. I also know there were two different types of span. This is 4 metres, the span of this tailplane. I know that's off a long span F2.b tailplane. Okay, how do I know that? Because on the short span, on the tailplane rib, they had the cutouts. Yeah? So this is a later one, so they probably said, look, there's no need to waste time cutting those out. We'll just put as straight cuts. So probably that was done for production reasons. So yeah, I can identify what rib that's come from. That's just an end rib, one on the end here. It's a bit shorter. It's got the angle cut in it to allow it to go around the rib like so. There's the elevator. It hasn't got the steel. That'll have a steel or a 4130 tube spar through, same as the leading edge, but I just set it up to give you an idea how that's going to look. It'll have a control horn built on it. which is a very difficult thing to make. We have to CNC a pressing mould to get all the shape right. There's a bit of messing around with that, but we're onto that. We're starting to make this stuff. That's the Bristol in America. I'm working with these guys a fair bit. They're very helpful with dimensions and different things. It is a replica. They have apparently an original fuselage there, one of 6 that came out of Scotland. But this one's a replica, not a very good replica. The wings are basically trashed. They can't be used. In fact, most of the aeroplane, you wouldn't fly in it. It would need complete rebuilding. But it does give you an idea of how the wings are going to look. So we're building the wings as per original, the empennage as per original. Tail, undercarriage will be near as damn it original. The only difference is the fuselage is made out of steel, 4130. The reason for that is it follows similar lines to the original Bristol pattern, but clearly we're dropping a big engine onto the front of it. It has to be a serviceable aeroplane. We don't want this to sit in a shed. We want this to be out flying a lot. And for maintenance reasons as well, we don't want to have to unstitch the fabric every few weeks to check that the wood hasn't broken or cracked, etc., etc. So as you can see there, the engine mounts will go down into the tubes here. So the engine will sit here, the pilot sits in here, and then the gunner will be behind. So we've still got an enormous amount of work to do on that fuselage. That's basically a Rolls-Royce cockpit. Okay, they vary a bit, the instrument panels. Are we going to use original instruments, you ask? Well, here we have an original World War I Zenith Mark 5A altimeter. Okay, and that's the start of it. I've got a man searching the UK at the moment for other bits and pieces as you see it. The Mark 5A Zenith altimeter goes up to 20,000 feet. Often in the Bristol they use the Mark 5B, which goes to 28,000 feet. It doesn't matter, I might pick up one at some stage. So. Yes, Max?
Has the B version got Bluetooth?
No, not quite. Not quite. An early version of it. For those aviators here, you normally have a millibar subscale setting that you can set that for sea level. You have something similar in that you can set your airfield height. What are we here? About 300 feet. So you set that and then you could read height above sea level in effect. Does it have error? My word, it has some error. It's basically just an aneroid capsule in there that is temperature compensated to some degree, but it's only a fixed compensation. Surprisingly, they put these things in chambers. I haven't gone flying yet, but really in a Victor Air Tour, the static pressures are going to be error in the actual cabin. Perhaps it'd be better to take it up in Bruce's swap with. They've found about a 400-foot error at 10,000 feet, so that's not bad. You know, it's pretty good. So yeah, that's World War I. Yeah, so we've got a bit of work to do on that. The back of the Vickers gun, control, rudder bar, etc. There's the pilot seat. Guess what? I found a manufacturer that's actually made 2 in the last few years. Need to know his name. I haven't got the price yet. That might. But yeah, so I've spoken to the aeronautical engineer about this. Now, clearly, we're not going to certify this as a 16G seat, which is what all your seats should be certified at now. We're going to go for a 9G, but this sits on rails on top of the fuel tank. So we're going to try and get the old certification in this, but we're certainly going to have the original seat. It's got to look right, you know. It's got to be right. So, and there's the seat sitting in there in the pilot's area. Now the gunner just sat on this little movable seat pan, if you like. He also had, it's just in here, like a little saddle that he unclipped. He clipped up the other side. He whizzed his bottom round and got the machine guns and went for it. It's going to be interesting to see how CASA takes to this arrangement, but anyway, we'll just have to work with that. And it'll all be the same in this aeroplane. It'll all be set up. I've just started the issue with the police about collector's licence to fit the guns, etc. But they'll be just mock clearly. Yeah. That's just another type, looks like perhaps a Hispano engine or something. Now the wheels, UK, they're going to be made in the UK. A vintage car maker is going to make them. And because the tyre size is different to the Palmer wheels, we've got to start off with what tyres we can get, and then we build the wheel from that. Tyre size in First World War on aeroplanes is actually full dimension of the wheel. So it's a 750mm by 125mm, okay? That gives you about a 19-inch rim. So that's what we're going to end up with. We can get Michelin tyres, we can get Dunlop tyres to fit that. They will have treads on them. Some people, they grind away with planers and get rid of the treads. So, yep. Okay, there's just a picture in the factory. Remember I mentioned about the fuel tank with a hole in it? And the Vickers gun sitting through there? That's from Filton in Bristol during the First World War, so it gives you an idea what they're up to. Now, just as an aside, the Americans, being Americans, you know, we're going to mass produce fighters for the First World War, for the war effort. So we're going to build 2,000 Bristol fighters. And that was the order, 2,000. But we're going to put Liberty engines in them. Guess what? Didn't work. They built just 3 aeroplanes and they all come to grief. They didn't fly. One, the fabric flew off, so that the order of 2,000 Bristols was cancelled. And that's the Curtiss factory in America building Bristol fighters. Okay? But the whole thing was a complete disaster. So. Right, okay, I just want to finish off. Any questions on any of that? Look, it's a big topic and I've really just gone over it very quickly, but I just want to finish off. I got quite a good little video of 3 Bristols in the UK flying in formation. It'll give you a feel of what we're going to see in a couple of years' time. And that's the target date. In October 2016, the F2.b flew for the first time 100 years ago. So that's a really good target date if we can get it finished. If we don't, well, we'll be close to the end of the First World War, I guess, 100 years, yeah.
Are you doing the test flight?
It's a good question. Clearly I don't fly First World War I aeroplanes, I do fly other types. One or two things will happen. I'll be treating this thing very seriously. I will be talking to test pilots in the UK, and spending time over there. If I can get myself up to speed to a standard that they're happy with, I may well do the first test flight. If I don't, and if we feel as though, you know, it would be better to bring out a test pilot from the UK to do it, that's what I'll do. But I will be involved in the test program. It will be a proper, a full test program. It will have all the official paperwork and we'll just work through everything. It's too serious an aeroplane not to do that. We've got to know exactly. You'll notice that the seat itself has a cushion. Well, that can be removed because initially we're going to wear parachutes, but it'll be the sit-on type that we'll be using for the test flight. But yeah, we'll be treating that very professionally and carefully. So yeah. Okay, I've just got to